merging in R. So first we're going to go through the joining function, and that's within Tidyverse. So you'll need to load Tidyverse first. I'm going to hit Control Enter to load that on my computer. So first, we're going to make some data sets to work with. I've titled the first one left data, and it's going to have X row that's 1 through 5, and then I labeled the next column LY, standing for left y-axis, and then I have A through E with the L next to it, so you know that it's the left data. And then for the right data, I've done a similar thing, except I have the X going from 3 to 6, so there's a little bit difference between those two data sets. And then again with the A through D, but with R on the end of it for right. So we can look at those. So that's what we're working with. So there are 4 main types of joining. The first one's called inner join that we're going to work through. So the arguments that it takes is the 2 data sets that we're going to work with. So let's put left data, right data. And then the next argument's by. So that's telling this function which column we want to merge them on. So we'll merge on X because that's the column that these 2 data sets have in common. And so what inner join's going to do is it's going to take the observations that both data sets have in that X column. So if we see in our left data, we had, again, in that X column, 1 through 5. And then the right data, we had 3 through 6. So in the inner data that we just created with that join function, we should see 3 through 5. And we do. The next type of join we're going to talk through is a left join. So this one takes the exact same arguments, and this time it's going to keep all of the data in the X column that the left data set has. So let's run that and look. Left join is what I wanted to look at. Okay, so now we can see that this data set kept all 1 through 5 in that X column because that was in the original left data set. And when in the right Y, it just put an NA when there were not observations in that X column. So similarly, we have right join, which, as you might guess, is going to take within that X column that we're merging by, it's gonna take all of the X observations that are in the right data set. So as you can see, in our original right data, we had 3 through 6, and now in our right join, we again have 3 through 6, and since that left data set didn't have a 6 in the X, it has an NA here. Then our last core for join functions would be our full join, and that is going to keep all observations in both of the data sets that are in that X column. So we should see 1 through 6. As we see, we have all of the X observations that were in either of the left or right data set. And when we come across an X observation that wasn't in one of the data sets, like in the left data set, as we saw, they only had 1 through 5 in the X, and so in the 6 we get an NA. And same for 1 and 2, since those weren't present in the right data set, we get NAs there. So it's full is taking every observation in that X column from either of them. So I quickly wanted to show you how we can make some more presentable tables, since the default tables that we have are not the easiest to look at. So we're gonna use the GT packages to do that. So if you don't have those, we'll just do install package GT. I'm not gonna run that line because I already have that. But I will load that GT with my library function. And so what we're gonna do here is create a variable name for this new table that we're making so that we can open it up later. And we take our GT function, we put in the name of the data set we want to look at, and then I've also piped in this tab header function, which is going to give that new table a title. So for our left data, I titled it left data, right data set, I titled it right data. So I'll run those, and then to make them pop up in our viewer, I'm just going to call those variable names. And so now in our viewer, we can see these prettier representations of our data sets here. Alright, we also have some less common join functions called semi-join and anti-join. So I'll just show you what happens when we run that. It's going to take the same arguments. And if we look at our semi-join, we see that it's keeping only the observations that are in both of the left and right data, as we saw, because that looks the same as the X column looks the same as our inner join. That 3 through 5 that both of those data sets share. But this time it's only kept this LY column that was from that original left data set, and it does not have the RY column from the right data set. Then anti-join kind of works the opposite way. We'll see. If we open that up, we only have the observations in the X that were not present in the left data set, or in the right data set, that 1 and 2. And again, we only have the columns from the left data set, so this LY and not the RY. So kind of similarly, we have the merge function, same as our join functions, but merge is the RBase function to do that procedure of joining two data sets or merging two data sets. They're synonyms here. Merge has one function that does all of the different types of joinings that we saw were in a different function for each type in joining. It's all the same in merging. And to get different results here, we're just going to use different arguments. So the default here is going to give you an inner join. So it takes the same arguments, the first data set, second data set, and which columns we're joining by, the by argument, which is the exact same as all of those join functions that we already went through. So we see here we have in the X column 3 through 5, and we've got both our left and right Y column, which we can check here is the same result as our inner join. So to get those other types of joins, as I briefly stated before, we're gonna use some different arguments. So the two arguments that are gonna get us these results are all X and all Y. So all X, if that's set to true, it's gonna keep all observations in the first data set, otherwise known as our left data set, and in this merge function, it would be known as our X data set. All of left, first, x, all of that means the same thing. So if we set that to true, we should get the same result as our left join. So as we can see, we have all of the observations in the x column from our left data set, 1 through 5, and we have NAs in that 1 and 2 because they're not present in the right data set. If we look at our left join here, it's the same result. So, very similarly, if we set all but y true, we get a right join. So we got our 3 through 6, and let's check and make sure that it is the same. Here's our right join data table, exactly the same. And then for our full join, we're going to set all.x and all.y true, so that it's going to keep all observations in the first data set and all observations in the second data set. We've got 1 through 6, and we've got our NAs where there are not those observations in the original data sets. So if we look at our full join once again, we see we have the same result. So some more complex things that we can do here in both the merging function and all of our join functions, because they do take the same arguments. If we wanted to merge on multiple columns, because multiple columns are the same in both, we can do that. So to show that, I'm going to mutate our original left and right data sets and add a new column called Z. That's just going to be A through E for the left one, and for the right one I have them as C through F because I want these letters to line up and be the same in both of the data sets so that there's matches, so it will merge properly. Alright, so how we can specify two different columns that we want to merge by, we're going to create a vector in that by argument. So we're going to use that C so that we can create a vector and specify by multiple different columns at the same time. So when we run that, we see here we have our X as we have for all of our inner joins, 3 through 5, but now we also have Z, C through D, because those two data sets we had matching observations in that Z column. If we don't specify the Z in the by, what it's going to do is give us two separate columns of Z for both of the data sets. So this ZX is from the left data set and the ZY is from the right data set. Because as I mentioned before, in merge, the left is X data set and the right is the Y data set. So that's why it's doing that. If we want to merge on multiple data sets, what we're going to do is do the first merge or join and then run another merge or join. So we have our inner join result. That was our first join here. And then if we want to tie that together with our new left data 2, we would run this new merge line here. And this time I want to merge by X and LY because that LY column is in both our inner join data set and our left data 2 set. So if I had not specified that LY, again, it would have created a result that looks more like this, where it would say LYX and LYY. But since we have those matching observations there, it's easiest if we just specify that we want to merge on that column. Yeah, thank you. I hope you learned about joining and merging today.